Yeah, thank you for having me. And I would like to start out with I'm Dave Coleman, CEO of PickNik, and start with a big picture of where MoveIt's at. I guess before that, though, next slide, um, the agenda. Next slide. So PickNik Robotics, we're in Colorado in the United States, and we've been around for 6 years now. Team's growing quick, so just you see we have a very talented team of people who build custom robot software in the ROS ecosystem, and in particular MoveIt. Next slide, please. And so our mission is to make this platform of software that can do all sorts of multi-purpose tasks. And we're really excited about what we've been able to accomplish so far. So the dream, of course, is this ROS-I robot idea where it can do all these unstructured tasks. It can do industrial factory type tasks, of course, but also a lot of domestic tasks in your home, laundry, pancake making, dishwashing. So we're far off from this, but it has been done before in a very experimental approach at Willow Garage, and we hope to make that more mainstream in the future. Next slide. So MoveIt started in 2010 at Willow Garage, where same time ROS was developed. So it was developed as the manipulation package for the ROS ecosystem, and it's gone through a lot of iterations since then. Last year we announced MoveIt 2.0, which is simply MoveIt for ROS2, and whispers are on the street of what will MoveIt 3 be like, and what API changes, and what's the next big revolution in MoveIt 2. And the difference between MoveIt 1 and MoveIt 2 is unlike what Matt Robinson was talking about with this at Sweary, their strategy of having the same library support ROS 1 and ROS 2, we took a different approach. Has lots of pluses and minuses. It's unclear which one's better, but we actually just did a straight port of everything in MoveIt 1 to MoveIt 2, and we're still syncing the two code repositories through Git, so code syncing, but they are in fact different versions. Next slide. And the ecosystem of MoveIt keeps growing. There's a lot of different plugins to do different types of things. Some of them are more mainstream supported and like more recommended, like FCL is maybe the more streamlined, fast collision checking library, but it gives you a lot of options and allows you to benchmark. So different types of applications have different needs, and so you can experiment through which ones are best for you, and the tutorials walk you through how to use each one of these. Next slide, please. And just our latest update in numbers for this year, a lot of robots have been used with MoveIt. It's very robot agnostic, which we're very proud of. And these are some rough metrics to gauge the popularity of how many downloads we get and how much has been cited in the literature. A lot of researchers use MoveIt for their publications. And yeah, our GitHub users and code contributors has continued to grow. 262 people have contributed to this project over its lifespan. Next slide, please. And a little more about our community. We'll be at ROSCON next month with a workshop about how to use MoveIt for mobile manipulation. Something we're really excited about is combining the navigation side with ARMS. And I've heard several talks this morning talk about that combination. It seems like a hot topic right now. Our World MoveIt Days, our annual hackathon, it'll probably be in the spring again. And finally, we have monthly meetings where we discuss as like a ROS2 TSC working group issues with the MoveIt community. Next slide, please. And so just a little high level of what we've been doing at PickNik and with some of our partners and collaborators and customers in deploying MoveIt in real-world applications. Next slide, please. So we're seeing it used in just in really places way beyond the factory. And I think this is really cool to see that the traditional constraints of a conveyor belt or an area that you can completely CAD and structured is kind of, we're able to advance beyond that now as software gets more powerful, as perception and grasping algorithms are being taken out into more of the quote real world. So one of our biggest projects lately has been in agriculture and actually harvesting produce out of plants. And these are just really tricky because of the different lighting changes from being exposed to the sun, the challenges on the like waterproofing, the hardware side, but also just plants are non-rigid, meaning that they move when you hit them and they're flexible, and so the planning problem there becomes a lot harder. Another area we've seen MoveIt used a lot in the past few years is in food production systems, particularly like smart kitchens. This is a Samsung prototype platform that they demonstrated at CES in the middle picture here. But of course, lots of usages MoveIt for bin picking and logistics, which maybe is the most applicable to the ROS-Industrial user base or viewership here. Next slide, please. So going beyond land, we've seen MoveIt used in a lot of underwater applications. So how do you control the robot arms to do useful things without a human operator nearby? This gets into, there is a human in the loop at some point, kind of giving it guidance, and you want to keep it as high level as possible because of latency and bandwidth issues of using communication over wireless water optics. And so, yeah, the MoveIt's been used in a lot of these different applications for ROVs. Next slide. And finally, air, or I should have said space here. We've been using MoveIt a lot in different space applications. The Robonaut program uses MoveIt on the ISS, International Space Station, to assist astronauts, and still a little bit experimental, of course, but the idea being that astronauts are very expensive to have in space and also dangerous. So using robotics as much as possible to augment the time that humans spend in space, particularly so like in orbit satellite servicing, being able to repair satellites that need upgrades or that have gone out of, like, or otherwise garbage, being able to capture those and actually reattach things. A number of companies are investigating using MoveIt for those things. This is a new burgeoning field, but the space industry is definitely growing a lot. And finally, there's a big push internationally, NASA, but many other space programs across the world to colonize the moon. And a lot of what's being talked about is how do we actually send materials down and actually start the construction with robot arms before astronauts arrive, or during periods where astronauts are not present, because they'll be coming on and off the surface. Next slide, please. And so this is a new thrust for PickNik, and for something that we're thinking about a lot lately is how do you not have a fully autonomous system, but actually be partly supervised, not teleoperation, but having an operator at a high level, giving it missions, objectives, and execute that semi-autonomously. And I think this is also applicable to factory floors. As we get more into mobile manipulation, there's going to be just guaranteed situations that we couldn't see arise as a mobile robot was driving across an industrial environment and something gets in its way, something falls over, unexpected. A human would probably need to be there to, like, maybe remotely help it through that. It's something we see a lot in the autonomous vehicle industry, which is more mature than maybe a mobile manipulation, but I think it's we're all moving towards. Next slide, please. So in this section, I would just want to give more of an update on the MoveIt 2 roadmap, getting a lot more technical here, and the progress made on the MoveIt migration. Next slide. So here's a big number. We have a spreadsheet. We did the calculations. We estimate that we're 98.5% complete with the full migration. The things blocking us are largely because there's things in ROS-2 that aren't quite perfectly tied up and around the parameter server, which is no longer called a parameter server, but just the parameters and launch files. So we're working with Open Robotics and other members of the technical steering committee of ROS-2 to fix those. As we just upgraded to Galactic and Rolling, a lot of those things are now actually out beyond Foxy. So we should be seeing the MoveIt Setup Assistant finally released as those can get wrapped up. And then a few of the more outer things like the Pose Motion Planner and Python is something that we've deprioritized because we typically work in C++, but we know a lot of our users care a lot about the usability, ease of use of Python. A few stats, there's been 340 PRs, and there's a pretty big difference between MoveIt 1 and MoveIt 2 at this point. And finally, we've doubled the number of GitHub stars for the MoveIt 2 repo. So we have separate repositories, and we're kind of measuring the popularity. Of course, we still have a lot of holdouts using MoveIt 1, but we're really starting to see that momentum of the migration because we can say, next slide, we have pretty good feature parity. So here in this table, which turns out I can't see the the font here, but it lays out all the main features in MoveIt 1 and MoveIt 2. It kind of gives you a checkbox if it's done or if it's sitting in a pull request that's almost merged. But if you can't see this picture, go to our to the MoveIt.ros.org's website, and there's a blog post probably like the third or fourth down outlining that. And we have been updating this throughout the summer as things mature even further. So I guess some of the highlights on this table I would point out are just like hybrid planning is something, and differential base planning, composable nodes. I'll get to these in a second in the next slide. Yeah, so the task constructor recently has been fully ported, which is this high-level task planning framework, so that you don't have, the MoveIt doesn't just do like motion plans, but also can sequence a multi-step like grasp and pick up and move over here and open this. Some of our visualization tools, a lot of infrastructure improvements around code quality with GitHub Actions. We're using the ROS-Industrial CI, and we've been happy with what it's been able to provide. MoveIt, previously we're using a custom MoveIt version. Lots of improvements on servo and OMPL and ROS2 control and hybrid planning. Next slide. So in these videos it's about to show, next slide. See if they can play. This is just showing our demonstrations of ROS2 planning in RViz with MoveIt. And a lot of people have since taken these demonstrations and added them to things like the that work presented earlier today around the easy manipulation setup approach. So we're happy to see that a lot of members of the ROS-Industrial Consortium are able to use MoveIt 2 already so successfully. That would be the easy manipulation deployment. That's what you guys were talking about earlier. Next slide, please. And so in this section, I just want to talk about some of the new features in MoveIt 2. So it's not just a straight port, but we are trying to improve the real-time capabilities. ROS1, they purposely did not focus on real-time, just as a design decision to make it a lot simpler for researchers and rapid iteration. But here we've been making visual servoing way faster, and the ability to react to human input and do dynamic scene updates. Next slide. Another big thrust of MoveIt 2 has been the hybrid planning. And so we now can actually have two control loops running, similar to how the Navigation 2 stack works. One is a global planner, which is like RRT style, plans their own obstacles. And at the lower level, we have an inverse kinematic space planner that has a much faster cycle time and like control frequency. And I think this has been merged into MoveIt 2 at this point. This actually might be a little outdated, this slide. Next slide, please. There's been a lot of work going into combining ROS2 controllers with MoveIt 2 so that we actually can run on hardware. And so I'll talk about that in a minute. But yeah, that's coming along. And finally, the next slide, the PILS Industrial Motion Planner provides a lot more traditional approaches to robot motions, like point-to-point and linear and circular. And that's been merged into MoveIt 1, which is one of our first steps. And then we are working on porting it to MoveIt 2. But that will allow you to take any robot hardware, like a robot arm, and program it like you do in a traditional industrial arm that you would get out of the box from like one of the big companies. The next section, next slide, please, is just talking about how one of the blockers for us in using MoveIt 2 has been having good hardware support. And we didn't want to use the ROS bridge to kind of switch over to a ROS1 area for the controllers. But we know that, so we wanted to have like the fast response rate of having a straight communication purely over DDS. And so one of the issues in adoption we've seen is just not having enough companies supporting ROS2 drivers. So we've been talking to a lot of companies, convincing them that it is time to port, that it is stable enough. There's a lot of big companies supporting this. And so just as a quick highlight, next slide, ROS2 control we've gotten really involved in. For example, adding a minutes controller is something that a lot of our customers have asked for. It's so that you can interact with the world in a more soft way, basically. And so there's a pull request that's been open for a while on that that's about to be merged. We've extended the joint controller to support multiple interfaces, now having better abilities to load and stop hardware interfaces, supporting grippers, fake hardware. So it's a lot of progress on that side. Next slide, please. In terms of mobile manipulation side, we do have the Hello Robot working in ROS2 now. And part of that effort with them was to have MoveIt be able to plan for the diff drive itself. So it if you want to reach over to something that your arm can't quite reach in a fixed space, it'll actually control the wheels to extend its working area. It's not well suited because of the just computational limitations of fully modeling a 3D environment. It's not well suited for navigating over long distances like a full warehouse. You'd still want to switch to like a navigation 2 type planner. But if you are working in a local area, we can now synchronize the two in ROS2. Next slide, as Matt Robinson mentioned earlier, we work together with the Swery folks and Universal Robots to create drivers for the UR5 and 3 and 10 and whatever other ones they have now. And so we've had a beta release of that and another release that's a lot more polished and are using that every day. So I know this is a very popular robot arm and we're excited to just remind everyone that this is now available in ROS2. So upgrade your systems. And finally, something we haven't announced before, next slide, is that we recently created Canova drivers for the Gen 3 arms for ROS2. I don't think those are publicly available yet, but stay tuned for that. Those are active development right now. And just going forward with MoveIt 2, next slide, we're talking about what MoveIt 3 is going to be, and basically, next slide, we're doing a lot of work on being able to dynamically change end effectors at runtime. This is something that we've heard for years as a need, and so if you want to change your tooling, that it'll allow that, component nodes, lifecycle management, and basically this will be a hard break from MoveIt 1.0. We won't be syncing with the ROS1 version anymore. Next slide. On the MoveIt roadmap, you can see this on our website. There's a lot of features in the works with various levels of work in progress. Next slide. We've released successfully to Foxy, Debians, and to Galactic, and most recently to Rolling. So we're now releasing Rolling quite frequently, and we actually really like having that because we can not have to build from source all the time, but actually have this actively developed one. And we had a Windows support recently in collaboration with Microsoft. And finally, if you want to get more involved, next slide, there's a link here about finding out more. We encourage contributions to documentation or bugs or features or just filing issues. Thank you. Next slide. Yeah, time for questions.